Hello, we're here with Hilde Sevens, who is the Senior Product Line Manager of Digital Factory at Autodesk. Thank you for being here, Hilde.
You're very welcome.
So tell us a little bit about yourself and your role at Autodesk.
So I'm Senior Product Line Manager for the Digital Factory products, and I've been at Autodesk for 4 years. And before that, I've been at different companies, but I've also been in the industry, so I've done design of plastic parts, of molds, as well as interior parts for automotive. So I have a little bit of industry history as well as software development history. So for Autodesk, in the Digital Factory group, we work on extending digital prototyping into the factory.
Okay.
We have 3 distinct product lines that help with that. And so our customers can use those in order to take the digital prototype from the design area all the way into the factory, meaning doing things like designing tooling, because you want to manufacture your products, simulating the manufacturing process, because you want to make sure that whatever comes out of manufacturing is the right thing.
Right.
And then also doing simulations of complete factories so that you have a better understanding of the digital situation before you have to go into the real world, which is a lot cheaper to keep it digital, get a good understanding of your factory, simulate that before you actually have to implement it in the physical world.
So how does Moldflow contribute to the Autodesk digital prototyping experience?
So Moldflow is one of those product lines, and it's specifically geared towards plastics simulation, so plastics for injection molding. And a lot of our products in the world are made with injection molding. Typically, most of the plastic parts that you see are made with injection molding. Now, when you design a plastic part, you want to have an understanding of how will this part look, how will it behave when it comes out of a mold, when it's manufactured. And Moldflow allows you to simulate the part as well as the mold, and not only validate that the part will come out right, but also validate and optimize your mold, your process, all of that. That's where Moldflow comes into play in digital prototyping, because you can take the digital prototype of the design and you can simulate that digital prototype so that you get a better understanding in the digital world versus having immediately to go to the physical world.
Good. So what key things are you doing to enable users to achieve affordable innovation?
Right. So
Right.
well, so there's different ways of doing that, of course. But one of the ways we do that is we basically provide a portfolio of software solutions that address specific needs for specific users, rather than maybe giving a complete extensive set of capabilities to somebody who only needs a fraction of that. So what I mean with that with Moldflow is that we have an extensive product range that allows a designer to do early validations of their designs, having the right tools for that designer to do those validations, making sure that the design will come out right when it's manufactured. But we also go towards having the tooling designer, allowing them to do simulation as well. So taking a step
Another
up,
step.
and then eventually going all the way into plastic simulation, kind of the specialist, either the CAE specialist or the plastic specialist can use these tools to do very advanced simulation capabilities. So optimizing cycle times, cooling, all of these things that are pretty much further advanced than the designer would need. And so we provide a variety of types of solutions for our customer base so that it's applicable. And maybe I can give you an example of a customer who does that.
Yes, please do.
Yeah, so we have Microsoft. Microsoft known for software, but they also do hardware, right? They do mouses, they do keyboards and things like that. So one of the things that they realized was that they were going into production, and at that moment in time when they would go into the physical world of the mold and producing the part, they did a check. They came to the realization that there were issues with the part. And so at that moment in time, they did firefighting analysis, I call that, right?
Okay.
So you take the part, you're in trouble, and you do an analysis to understand what's going on. Then, when you figure that out, you got to go back and do a design change. That is very expensive at that moment in time, because you're all the way in production at this point, right? So what they said is, you know, the firefighting analysis is not working. What we need to do is we need to move the analysis to the upfront design area. So what they're doing now is they're taking the design from industrial design phase. So they just have a surface maybe from their keyboard. And at that moment in time they say, okay, let's thicken the surface and do a quick analysis on the surface and see if this part is going to make it through manufacturing. If it's okay, fine, let's move to mechanical engineering, add the mechanical features to it, then do another analysis. So they're using the different tool sets for different users, do that in other analysis, and by the time they get to production, they're just optimizing. They don't need to make changes to the design. You know, they're good to go. All they're doing is optimizing cycle time, optimizing the cooling, optimizing the tools, that kind of thing. And that is a much better process.
Sure.
They can innovate much better that way than doing all the firefighting at the back end.
That's interesting. I had never thought of that before. So how can Moldflow help users to mitigate the environmental impact that their designs contribute to the environment?
Okay, well, Moldflow has an extensive database of materials. So in order to do analysis, typically you have to put the right information into the analysis to get the right information out. So whatever information you put in, there's a variety of things that you put in, but one of them is the material, right?
Okay.
If you do plastic simulation, the plastic information that you put into the analysis tool will determine how accurate your analysis is, right? So we build up a complete database of materials. We have 2 laboratories in the world, one in Melbourne, Australia, and one in Ithaca, New York. And those labs specialize in testing materials for material suppliers, for customers, etc. With that testing, we can get exactly the right properties of those materials that we can input into the analysis tool and therefore get a much better accurate result of analysis. Now what we've done is we've over 8,000 materials commercially available in that database, and we also have about 2,400 materials available that are proprietary to customers.
Okay.
So what we've done is we've taken those materials and we've said for the 2010 release, let's bring to the surface what the environmental impact of a material is. So we added 2 environmental impact indicators.
Wow.
One is recyclability. So we know, right, whether or not a material is recyclable. And there are standards in the world around that. So we've added that to the database, and we've also added energy usage. Because we know how much energy you need to melt a plastic for injection molding and things like that, right? How much pressure you need in the mold and things like that. So what we've done is we really took those 8,000 plus materials and we brought that information out so that when a user goes and looks at, you know, which material am I going to pick, he immediately can see, you know, this one is actually a better environmental choice than the other one.
That's great.
Yeah, so that's how we help our users to make the right decision.
Well, thank you
Oh,
for
you're very
coming here
welcome.
and sharing all this with us. And thank you for sharing this time with us.